Okay, so here we have a compound inequality. So this is a compound inequality. And this would be considered an and inequality because it's combined together as one, but there's two inequality symbols here. So 5x minus 6 must be greater than or equal to 4, and 5x minus 6 must be less than 19. So we work this problem we are solving still. Solving to us should always mean trying to isolate the variable. The variable in this case would be the x. The x is located in the center of this inequality. So we're focused on the center and the location of the x variable. So when we look at where x is, it's 5x minus 6. So we need to process, okay, well, if I want to get x by itself, I would need to move the other components that are in the same place as the x. So I have a 5 and I have a 6. So the 6 is going to move. It's a negative 6 subtracting from the x. So I'm going to add 6 to itself. Then you're going to cross each inequality symbol. Make sure you always know where you are in your problem. So we have 10 less than or equal to 5x less than 25. So we're looking at 5 times x still in the center. Remember, our goal is to get x by itself. So in that case, I would need to divide everything by the 5. So I'm going to divide 5 by itself. I'm going to go on the left side, cross the inequality, then go on the right side, cross the inequality. So 2 less than or equal to x less than 5. So this is our solution. We're going to graph that solution. And so we're reading it as x must be greater than or equal to 2. X must be less than 5. So when it's an and, the answer should be between them. So since my solution is between them, I know that I've done this correctly. So this is my graph, remember? And then my interval notation, the interval notation would be bracket 2 to 5 with a parenthesis. All right, so here we have another compound inequality, but this time we have an or inequality. Okay, we have an or inequality. So you're just going to solve each inequality separately. I'm going to solve them separately. So on the left side, I have 5x minus 3 is less than or equal to 10. So I'm going to add 3 to both sides. So 5x is less than or equal to 13. Then I'm going to divide both sides by 5. So x is less than or equal to 13 over 5. Okay? Then I'm going to go over to my right side and complete that inequality solution. So x plus 1 is greater than or equal to 5. I'm going to subtract 1 on both sides. X must be greater than or equal to 4. So I have x is less than or equal to 13 over 5, or x is greater than or equal to 4. That is my solution. That is the solution. You must have a value of x that is less than or equal to 13 over 5, or something that is greater than or equal to 4. So we're going to graph that to see what that looks like. So 13 over 5 is about 2 3/5. So that means it's smaller than 4. So that's how I know which side of 4 it would go on. So x is less than or equal to. So it's a bracket, less than. And then x is greater than or equal to 4. It's a bracket, greater than. So when we have ors, our solutions will usually go in separate directions. So we're going to, from left to right, read interval notation, negative infinity to 13 over 5, union with 4 to infinity. So we use this U, the union symbol, to unite these two sides together, okay? So x can be either or, either something negative from negative infinity to 13 over 5, or something that's 4 to infinity. So you have your and compound inequalities where when you solve them, your solution should be between them. And then you have your or compound inequalities. When you solve them, they should go apart. And that is solving compound inequalities.